Okay. Hello, everyone. Today we will have a exercise class for chapter 2. I have these questions: choice questions, fill in blank questions, short answer questions, and comprehensive application questions. And these questions probably will be in the final examinations. So pay attention to these kind of questions. So choice questions, and there are 4 questions. Then we will look at the questions from the number 1. In the noiseless channel with 4 kilohertz bandwidth, the maximum data transmission rate is hoped to be 24 kilobit per second. Then the number of signal levels is what? Which one? A, B, C, or D? Okay. Noiseless channel, right? Noiseless channel, we should use the next theorem. Next theorem tells that capacity the channel capacity is 2 times B times log 2 is the log 2 log V or M. So here B is 4 kilo. B is 4 kilo, right? 4 kilohertz. And C is 24 kilo, right? So C equals to 2B times log 2 capital M. Capital M is the number of signal levels. Which one? B is 4 kilo. Then 2B is 8 kilo or 8,000, right? C is 24,000. So log 2M. So log 2M is log 2M is 3, right? So 2B is 8,000. So log is equal to 3. So capital M, the number of signal level is 8. So the answer is B. The answer is B, right? Answer is B. Is B. the answer, right? So for noisiness channel, we should use next theorem. And we should remember the equation. The capacity or the bandwidth or the maximum data transmission rate denoted by capital C equals 2B times 2 raised to capital M. Capital M is the number of signal level. This is the question 1. Now, look at the question 2. For a noiseless channel with 4 kilohertz bandwidth, if 256 signal levels are used, the communication capacity achieved is how many kilo bps? So for noiseless channel, we should use the Nyquist theorem, right? The Nyquist theorem is bandwidth B, capital B is 4 kilo, 4 kilo. 256 signal level. So capital M is 256. So the capacity capital C is what? Capital C is 2B, right? 2B, the 4 kilo, right? 2B, 2 times B, B is 4 kilo, right? Then log 2 capital log 2 256. So the capacity is 2 times 4 equals 2 times 4 equals 8,000, right? And the log is 8. So 8 times 8, 64,000. So the capacity, communication capacity achieved is 64 kilo bps. So kilo 1,000, 64. So for noiseless channel, we should remember this equation. Now let's look at a channel with noisy channel. So another type of channel is noisy channel. So if we know the signal to noise ratio of the channel, we should use Shannon theorem to determine the capacity, right? So for the noisy channel, assume that the bandwidth of a channel is the 3 kilohertz and a data rate of 24 kilohertz is expected. The signal to noise ratio of the channel, according to the theorem, is, so we should remember the Shannon theorem equation, capital C equals B log 2 1 plus 1 plus signal to noise ratio. So capital C is 24 kilo. So C is 24 kilo, right? B is 3 kilohertz, right? Times log 2 log 2, sorry. So what's the signal to noise ratio? Log should be 8, right? Log should be 8. So 1 plus S over N should be 256. So S over N is 255, right? This is okay. So okay. The answer to question 3 is C, 255. We should remember the equation of Shannon theorem. Capital C equals B times log 2 1 plus S over N. S over N is the signal to noise ratio of the channel. Okay, this is question 3. Question 4. Question 4. Which one runs with best real-time performance? The best real-time performance is circuit switching. Circuit switching. The basic switching method includes packet switching, circuit switching, datagram switching. But the circuit switching is the runs with the best real-time performance. Fill in blank questions. In the physical layer, 4 basic multiplexing schemes includes TDM, FDM, WDM, and CDM. In the physical channel or in the physical layer, 4 basic multiplexing schemes includes TDM, FDM, WDM, and CDM. TDM means time division multiplexing, frequency division multiplexing, wave division multiplexing and code division multiplexing. And question 2, in the CDMA system, a station is assigned a chip sequence 000111011. Then this station send a 0 bit by transmitting what, and send a 1 bit by transmitting what. So if a chip sequence for this station is this one, then sending 0 bit by transmitting the 11111001000, and send 1 bit by transmitting the chip sequence itself 000111011. Question 3. In the even parity coding system, here even parity coding system, what bit is added to the end of the frame? So this bit is appended to the end of the sequence, should make the number of the 1 bit is even, not odd. So the 1 bit should add 1 bit. Why 1 bit? Because the 1, 2, 3, 4, 5, 6. So 6 is an even number. So here is 1 bit. Or the number of 1 in the original sequence is 5. So 1 bit should be appended to the end of the sequence. That make the whole number of 1 bit is even, right? So, in the odd parity coding system, 0 bit should be appended to the end of the sequence, right? So the question is easy. Short answer questions. Please write the full name. Please write the full names of the 4 multiplexing techniques in the physical layer and describe the main function of the physical layer. So FDM, the 4 multiplexing technique includes frequency division multiplexing, time division multiplexing, code division multiplexing, and wave division multiplexing. The main function of the physical layer is to transmit transparent bit stream. Then the comprehensive application questions. We have 6 questions. Question 1. A noiseless 3 kHz channel, 2 level signals. What is the maximum data rate? So look at noiseless. Noiseless channel, the maximum data rate F2C is 2B, right? 2B log log 2, sorry, log 2, 2, log 2, 2 here. The first 2 is the base. So log is 1, right? The value of log is 1. So the noise, 2B is 6 kilo, right? 6 kilo. So the maximum data rate is 6 kilo. 6 kilo bit per second. The bandwidth B, signal level capital V or capital M. The maximum data rate, capacity of the data rate, and the capacity of the channel denoted by capital C. Then by next theorem, we have the maximum data rate, capital C, equals 2B times log 2V. So the maximum data rate is 6,000 bits per second. Then we look at question 2. So the next theorem, the equation of the next theorem should be understood very well. Question 2. In the 4 kHz noiseless channel, the maximum data transmission rate is expected to 24 kHz. Then, what is the number of signal levels? So, this question is the same as the choice questions, right? So, if the signal consists the V discrete levels. Next theorem is the maximum data rate, capital C equals 2B log 2V, then 2V or 2M, 2V or 2M. So 24,000 equals 2 times 4,000 times log 2V. So log 2V equals 3. So V is 8. And the number of signal levels should be 8. So for the noiseless channel, we should use Next theorem. The equation is this one. Then, for noisy channel, the bandwidth of a channel is 3 kHz if the maximum data rate is 18 kbps. What is the signal to noise ratio? Shannon theorem tells us that capital C, the capacity or the maximum data rate, capital C equals B is B times log 2 1 plus S over N, signal to noisy ratio, S over N. Capital C is 18,000 bps. Capital B, the bandwidth, is 3,000 Hz. Then log 2 1 plus S over N, signal noise ratio is, so signal to noisy ratio is 43, right? Because log should be 6. Log should be 6, so the content, the value of the brace should be 64. So signal to noise ratio should be 63. So the noise ratio we should depend on the Shannon theory. In satellite communication channel, the length of a data frame is 3 bits. 3 bits is S bits. The error probability of each bit is PB. What is the error probability of each frame? PF. Satellite communication channel, the length of a data frame is S bits. The error probability of each bit is PB. PB is PB. The error probability of each bit is PB. The length, the number of the bits is S bits. So what is the error probability of each frame? PF. Okay, the result is 1 minus PB with the power of S, Y. The error probability of each frame, we cannot determine it directly. So we know we can determine the correct probability of each frame is this. This is the correct probability, right? The error probability is PB. The correct probability is 1 minus PB. And S bits all correct, then the frame is correct. So 1 minus PB with the power of S. So the correct probability is this. So the error probability of each frame is 1 minus. You understand? So the error probability we cannot determine directly, but we can determine the correct probability of each frame is 1 minus PB, the power of S. Then the error probability is 1 minus the correct probability. Question 4. Now, question 5. Question 5, we should determine the CRC calculation. To be transmitted message. To be transmitted message is capital M 1101011011 using CRC generator polynomial Gx is x4 plus x plus 1. Questions as follows. 1. What is the binary bit sequence of Gx? What is the CRC checking sequence? Please exhibit the middle calculating process. What is the to be transmitted frame with CRC checking sequence? Okay. The to be transmitted sequence is this one. It's this one. Using CRC, the generator polynomial Gx is this one. What is the binary bit sequence? Binary bit sequence is 1, 0, 0, 1, 1. Why? Because Gx Gx is x4 plus x plus 1, right? Means x times x4 plus 0 times, x3 plus 0 coefficient, right? 0 plus times x2 terms plus 1 times x1 plus 1 x0, right? So we read the coefficient 1, 0, 0, 1, 1. This is the binary bit sequence is 1, 0, 0, 1, 1. Then we get the binary bit sequence. This is equivalent to the letter, right? So the binary bit sequence is 1, 0, 0, 1, 1. What is the CRC checking sequence? Since the order of the highest order is x4, so the number of bit of CRC is 4. We should append 4 zeros at the end of the original message. So here, the to be transmitted message is this one. Before long division, we append 4 zeros. Why 4, not 5? The highest order term here is 4. So add 4 zeros at the end of the original message. Then we use non-division. We get the remain is 1110. 1110. So the checking sequence is 1110. And we use the calculation XOR. XOR. For example, if the 2 bits are different, then get 1. If the 2 bits are same, get 0. 0, 0, get 0. 1, 0, different, get 1. So we use XOR calculation. This is question 5. Okay. Do you understand question 5? Calculation for CRC code. Use non-division with XOR. This kind of question will be emerged in the final examination. Probably the number is different, but the method of calculation is the same. Question 5. Then look at question 6. Question 6. A communication link uses CRC with the generator polynomial gx, x4 plus x plus 1. Assume that the data sequence 101110 with CRC code has been received by the receiver. Then what is the length of the CRC code, and what is the binary bit sequence of the generator polynomial? Is the data sequence received correct? Please write out the CRC check-in process at the receiver end. So please think about these questions for a while. Then we will have a rest for 10 minutes. Okay, let's have a rest for 10 minutes. Next section, we will continue to illustrate the calculation of this kind of questions. Sorry. Okay. Microphone. The microphone is switched off. Okay. What are the two reasons for using layered protocols? So what is one possible disadvantage of using layered protocols? Among the other reasons for using layered protocols, using them leads to breaking up the design problems into smaller, more manageable pieces. And the layering means the protocols can be changed without affecting higher or lower ones. One possible disadvantage is the performance of a layered system is likely to be worse than the performance of a monolithic system, although it is extremely difficult to implement and manage a monolithic system. Okay, we have reviewed the homework, reviewed the exercises for chapter 1, and we have reviewed the exercises for chapter 2. Chapter 2. Okay, some students ask the questions. You haven't finished the homework 2, right? Some students have submitted the homework 1, but the homework 2 is not yet submitted. So we should write the homework 2. Homework 2 homework 2, this one. I hope you finished this homework by yourself after the class. Okay, it's different, right? Different. I am, because if I don't explain for the exercises or the homework, some students cannot know how to finish it. So I explain the exercises or homework in details. So after illustrations of this class, I believe most of you will finish the homework easily. And these questions will be emerged in the final examination. So I think the questions some important for improving the score of the final examination. That is why we spend some times to explain the homework. I have the files for the homework and exercises. For the exercises, the questions, the homework, the questions, that is, the homework is the subset of exercises, or exercises includes the homework. Some questions in the exercises is not in the homework, but the questions in the homework is in the exercises, So I explained the exercises in detail. Just now, I'm sorry, just now the microphone was switched off. And I will repeat it. I will review the answers. I will review the answers for chapter 2. Okay. Question 6 for homework 2. Okay. Yes. Yes, the mic was off between the two sections. I'm sorry. And I don't remember to turn on the mic. Sorry. And I will explain the question 6, right? Question 6 again. Okay. The communication link uses CRC. The communication link uses CRC with the generator polynomial Gx. Assume that the data sequence 101110 with CRC code has been received by the receiver. What is the length of CRC code? So, this is CRC calculation for sender to be transmitted, right, at the sender rate, at the sender end, this is to be transmitted, so it's the sender end. Is question 5. Question 6 for receiver end. This is the receiver end. They are different. Although they all although they both about CRC calculation, but they are different, right? So if you understand question 5, you should understand the difference between question 5 and 6. To be transmitted message is M. We should append several zeros, right? The number of zeros appended depends on the order. 4, right? The number of zeros appended depends on the 4, right? Okay. Question 6. For the receiver end, this is a 4. So the length of the CRC code is 4. And the binary bit sequence is 10011. Why we can get 10011? We will not explain again. The data sequence received, we should calculate by long division. Okay. Do you notice that here we didn't append any 0 bit, right? We didn't append any 0 bit, but here we append 4 zeros, right? Why? Because at the sender end, the CRC code will be calculated and appended here. So we should add 4 zeros to occupy the places of bits of CRC code. But at the receiver end, the data sequence includes the CRC code. So we need not append any 0 bit here. Do you understand? Do you understand? That is the difference between the receiver and the sender calculation of CRC. So after explain illustration of exercises 1 and exercises 2, I think it is very easy for you to finish the homework 2 and homework 1, right? And some of the questions were emerged in the final examination. That is why I illustrate in details the questions of exercises. If you have any questions, please send messages in the WeChat group. Okay. I did explain the all exercises. I did explain all exercises, right? Some students accused the OBE said, I haven't explained all the exercises, but I did explain all exercises. For example, choice questions, right? Choice questions, fill in blank questions, short answer questions, comprehensive application, right? I did explain all questions. And I explained the answers to chapter 1. The answers of chapter 1 we have explained last time. Okay. The difference between OSI reference model and the TCP/IP reference model. The utilization of the communication system denoted by eta. Eta is equal to the m divided by n times h plus m. M means the size of message, the useful message with m bytes. The total length of the stream transmitted in the physical channel is n times h plus m bytes. So eta utilization equals m divided by nh plus m, right? So the two reasons for using layered protocols, two reasons means the layered protocols needs to breaking up the design problem into smaller, more manageable pieces. And layering means the protocols can be changed without affecting higher or lower ones. Now, one possible disadvantage of using layered protocols, possible disadvantage should lies at the performance. The layered system is likely to be worse than the performance of a monolithic system. Also, it is extremely difficult to implement and manage the monolithic system. So, layered system should make the implement easier, breaking up the design problem into smaller, more manageable pieces. And it is without affecting higher and lower ones when protocols changing or updated. but the monocytic have higher performance, but monocytic system is difficult to implement and manage. So layered protocols has advantage and disadvantages. So we should analyze it. Okay. Do you understand? If you have any questions, you are welcome to send messages in the WeChat group. Unfortunately, my microphone was turned off before before noticing it. I talked much. Sorry. Okay, that's all for today. Thank you. Bye.